What if the tiredness you've been blamming on age isn't age at all? What if the fog that rolls in after lunch, the way your rings feel tighter by evening, the thirst that never quite goes away? What if all of that is your body trying to hand you a message it's been writing for years? Somewhere between the plate you eat off and the numbers your doctor circles in red, there's a conversation happening inside you right now, one most people never learn to listen to until it's shouting instead of whispering. This is the story of that conversation, not a diet, not a miracle, a biological negotiation that happens inside every one of us, every single day, whether we notice it or not. Here's where it starts. Every time you eat, your bloodstream fills with glucose, the fuel your cells need to function. But fuel sitting in the blood does nothing on its own. It has to get inside the cells, into the muscles, into the liver, into the brain, or it just circulates, causing quiet damage as it goes. The hormone responsible for that delivery is insulin. Produced by the pancreas, insulin acts like a key, unlocking the doors of your cells so glucose can move from the blood into the tissue where it's actually useful. For most of human history, this system worked quietly and efficiently, tuned by millions of years of evolution around meals that were infrequent, unprocessed, and modest in sugar. Then everything around us changed faster than our biology could keep up. Ultra-processed carbohydrates, sugar hidden inside foods that don't even taste sweet, meals eaten in front of screens, often too large, often too frequent, often stacked one on top of another with barely 3 hours between them. And so the key insulin has to work harder and harder, released in bigger and bigger amounts, trying to force doors that are slowly becoming stiff. Scientists call this insulin resistance. It's not a switch that flips overnight. It's a slope, one that can take 5, 10, sometimes 15 years to descend, mostly without a single obvious symptom, until eventually the pancreas can no longer keep pace and blood sugar itself begins to rise. That is, in simple terms, the road toward type 2 diabetes, a condition affecting hundreds of millions of people worldwide, many of whom don't yet know they're on that road at all. Here's the part almost nobody explains clearly. Insulin resistance isn't just about how much sugar or carbohydrate you eat. It's about how your body responds to it, and that response is shaped by sleep, by stress, by movement, by inflammation, by the timing of meals, and even by the bacteria living in your gut. Two people can eat the exact same bowl of rice and have completely different blood sugar spikes, because their underlying metabolic terrain is different. This is why blanket advice like simply, eat less sugar, so often fails people. It treats a symptom while ignoring the system. So let's talk about the system, piece by piece, the way researchers have come to understand it over the last few decades. The first and perhaps most underestimated factor is the order and composition of what you eat, not just the amount. Studies using continuous glucose monitors have shown something fascinating. Eating the exact same meal in a different sequence, protein and vegetables first, refined carbohydrates last, can blunt the blood sugar spike by a significant margin. Why? Because protein and fiber slow gastric emptying, meaning food leaves the stomach more gradually, so glucose trickles into the bloodstream instead of flooding it all at once. It's less about restriction and more about packing. Your body doesn't necessarily need less fuel. It needs that fuel delivered at a rate it can actually manage. This is where fiber becomes one of the most quietly powerful tools available, and it costs almost nothing. Soluble fiber, the kind found in legumes, oats, chia, and certain seeds, forms a gel-like substance when it meets water in the digestive tract. That gel physically slows the absorption of glucose. Lentils are a particularly interesting example, because on paper they're a carbohydrate, yet their fiber and protein content means they behave in the bloodstream more like a slow-release fuel source than a spike-inducing one. This is sometimes called the glycemic index paradox. A food can be technically a carb and still support stable blood sugar, depending entirely on what surrounds that carb: fiber, fat, protein, and even acidity. Which brings us to something researchers have studied with genuine curiosity: the role of acidity in slowing digestion. Vinegar, particularly the acetic acid within it, has been shown in multiple small clinical studies to modestly reduce the blood sugar rise that follows a carbohydrate-containing meal. The proposed mechanism is twofold. Acetic acid appears to slow stomach emptying, and it may also enhance the uptake of glucose into muscle tissue. It is not a cure, and the effect size in research is modest, not dramatic, but it illustrates a broader truth. Small, consistent inputs, applied before a meal rather than after, can shift the trajectory of that meal's impact on your body. Spices tell a similar story. Cinnamon, specifically the Ceylon variety rather than the more common cassia type, has been studied for its potential to improve insulin sensitivity, though researchers are careful to note that cassia cinnamon contains higher levels of a compound called coumarin, which in large regular doses may stress the liver. This distinction matters because most kitchen cabinets are stocked with cassia without anyone realizing there's a difference. It's a small detail, but it's the kind of detail that separates genuinely useful health information from advice repeated so often nobody stops to check if it's accurate. Now let's move beyond the plate, because here is where the story deepens in a way most videos on this topic never go. Blood sugar regulation is not purely a matter of food. It is deeply, measurably connected to inflammation, a slow-burning immune response that, when chronic, interferes with the very receptors insulin needs to do its job. Omega-3 fatty acids, found in fatty fish like salmon, sardines, and mackerel, have been studied for their anti-inflammatory properties, and some research suggests they may support healthier insulin signaling over time. This is not about chasing a single superfood. It's about recognizing that the body is an interconnected system, where a fire lit in one place, say, chronic low-grade inflammation from poor sleep or unresolved stress, can quietly interfere with a process happening somewhere else entirely, like glucose metabolism. And this leads to a factor that deserves far more attention than it typically receives: sleep. During deep sleep, the body undergoes hormonal recalibration, including regulation of cortisol, the primary stress hormone. Just a few nights of restricted or poor quality sleep have been shown in research to measurably reduce insulin sensitivity in otherwise healthy people, meaning the same meal, eaten after a bad night's sleep, can produce a noticeably higher blood sugar response than it would after a good one. This is not a minor footnote. It suggests that a person meticulously managing their diet while chronically undersleeping may be working against themselves without ever realizing where the resistance is coming from. Stress operates through a similar hormonal pathway. When cortisol rises, whether from a genuine threat or from the slow drip of everyday anxiety, financial pressure, or unresolved emotional weight, the body responds as though it needs immediate energy. It raises blood sugar in anticipation of a fight-or-flight demand that, in modern life, rarely actually arrives. The stress remains, the sugar rises, but the physical outlet our ancestors would have used, running, fighting, physically escaping the threat, almost never happens. Over time, this repeated hormonal signal can contribute to the same resistance pattern seen with diet and sleep. This is one of the more quietly profound truths in metabolic science. Your emotional state is not separate from your biochemistry. It is a direct participant in it. Movement, too, plays a role that goes beyond simple calorie burning. Muscle tissue is one of the largest reservoirs for glucose storage in the entire body. When muscles contract, they can take up glucose from the bloodstream through a pathway that doesn't even require much insulin at all. This is part of why even a short walk after a meal, something as unremarkable as 10 or 15 minutes, has been shown in research to meaningfully reduce the blood sugar spike that follows eating. It's a strange and hopeful discovery, because it means the tool isn't necessarily an hour at the gym. It can be as simple as standing up and moving your legs while the dishes are still on the table. So why, with all of this understanding available, do so many people still struggle? Part of the answer is psychological, and it's rarely discussed alongside the biology. Chronic health concerns, especially ones tied to something as unglamorous and slow-moving as blood sugar, tend to produce a kind of quiet fatigue in the people managing them. There's no dramatic before and after. There's no single day where everything visibly changes. Progress happens in decimal points on a lab report, and that kind of progress is notoriously hard for the human brain to feel motivated by. This is why sustainable change tends to come not from intensity, but from architecture, building an environment and a routine where the healthier choice requires less willpower, not more. Keeping vegetables washed and visible in the fridge, taking the walking shoes to the front door instead of the closet. Preparing a lentil soup on Sunday so that Tuesday's exhausted version of you doesn't have to choose between cooking and giving up. There is also a deeper, more human layer to this story, one that researchers studying longevity have circled back to again and again. Communities where people tend to live the longest, healthiest lives, often referred to in longevity research as regions with unusually high concentrations of centenarians, share certain patterns beyond diet, strong social connection, a continued sense of purpose, even into very old age. Regular, low-intensity physical activity, woven into daily life rather than scheduled as a separate task. None of these factors show up on a glucose meter directly, and yet they appear again and again in research correlating with better metabolic outcomes and longer, more independent lives. Isolation and a lack of purpose have been associated with elevated stress hormones, disrupted sleep, and reduced motivation to maintain healthy routines, a slow erosion that compounds over years. In other words, the loneliest version of a person and the healthiest version of that same person are rarely the same version at all. This is not a call to abandon medical care in favor of vague lifestyle philosophy, quite the opposite. Blood sugar management, particularly for anyone already diagnosed with prediabetes or type 2 diabetes, should always happen in partnership with a physician. Foods and habits that support insulin sensitivity, like the ones discussed here, can have real, measurable effects, and for some people on medication, those effects can be significant enough that dosage needs to be reassessed. That reassessment should never happen alone. Combining fiber-rich meals, vinegar, certain spices, and increased movement with existing diabetes medication without medical supervision can, in some cases, push blood sugar too low, which carries its own serious risks. The responsible path is not choosing between medicine and lifestyle. It's using both deliberately together, with a doctor watching the numbers as your body responds. What makes this topic worth sitting with isn't just the biology, though the biology is genuinely fascinating once you see how interconnected it all is. It's the reminder that most of the daily choices we treat as small, how we eat, how we sleep, how we move, who we spend time with, whether we carry stress or set it down, are not actually small at all. They are the quiet architecture of a body's future. The plate in front of you tonight, the walk you do or don't take after dinner, the hour you go to bed, the phone call you make to someone who might be lonelier than they let on, these are not separate categories of a well-lived life. Inside the body, they are the same conversation, running through the same hormonal pathways, shaping the same long, slow trajectory toward either resilience or decline. Nobody can promise you a specific number on a lab report, and anyone who does deserves your skepticism, not your trust. What the science can offer instead is something more honest and in its own way more encouraging, a body that responds. Not perfectly, not overnight, but consistently to the signals you send it, meal after meal, night after night, year after year. That responsiveness is not a small thing. It means the story isn't finished by a diagnosis or a difficult lab result. It means there is still a conversation happening, and you are still, every single day, a participant in how it unfolds. So maybe the real question isn't whether you can change a number by next month. Maybe it's simpler than that. What is one signal today that your body has been sending you quietly, that you're finally ready to listen to?